The following is Summer 2009 Math 263 Test 3 number 6. Consider a triangle with vertices 0, 0, 1, 0 and 1, 1 with density proportional to the square distance from origin. Now let me first sketch the domain 0, 0, 1, 0, 1, 1. And then the density is proportional to the square distance from the origin. The distance from origin is supposed to be with square root. Now here is the square distance, right? So that's the density. Now the question is then find out the mass. The mass of this triangle. Okay, the mass will be equal to, let me move it a little bit, integral from 0 to 1 for the x, and for the y will be from 0 to x of the density dy dx. Right? This is the domain and this is the density. Now then let's integrate this. I can pull the k out. Right, integral from 0 to 1, and if I integrate this with respect to y, I will get x squared y plus y cubed over 3 from 0 to x dx, and this is equals to k times integral from 0 to 1. I replace the y by x, right? I replace the y by x, I get x cubed, plus by that I will get x cubed over 3, and when the y equals to 0, then it becomes 0 dx, which is equals to, notice that this is, I write it down, this is, if I combine like terms, I will get 4 over 3 x cubed dx, right? Which if I integrate, I will get k 1/4 cancel. Let me write down 4 over 3 times 1 over 4 x to the 4th from 0 to 1, right? So I get k over 3, and the integral of x to the 4th from 0 to 1 is 1. So this will be the mass. Now how about the moment with respect to x-axis? The moment with respect to x-axis basically is the same integral with the mass, but I will insert y in there. Okay, I will insert the y. There will be integral from 0 to 1, integral from 0 to x, ky x squared plus y squared dy dx. Just like before, I pull the k out, integral from 0 to 1, and when I integrate with respect to y there, it will be x squared y squared over 2 plus that's y cubed, so y to the 4th over 4 from 0 to x dx. Now from here, I hope you see the routine. K times integral from 0 to 1, I replace the y by x, so I get x to the 4th over 2 plus x to the 4th over 4 dx, right? And that's k times integral from 0 to 1. If I combine like terms, I hope you see this is 3/4 x to the 4th dx. I hope I'm okay. Are you with me? And then this is k times 3/4 times 1/5 x to the 5th integral from 0 to 1. The limits from 0 to 1, which we know this will be equals to 1 here, right? This is equals to 1, then therefore if I compute this, I'll get 3k over 20. Okay, notice that this is the moment, this is not the y bar. If you want to find out what is the y bar, then you need to divide this moment with respect to x-axis by the mass. Okay, you need to, and I think you will get 9 over 20. Now let's move on to moment inertia with respect to x-axis. Now the same idea, this is actually the second moment with respect to x-axis, which means in the mass integral I will insert y squared. Now for the moment of x, I insert the y. Right now I will insert the y squared. It's k y squared x squared plus y squared dy dx. This is, again, I pull the k out. Now whenever you integrate with respect to y, I get x squared y cubed over 3 plus y to the 5th over 5 integral from 0, I mean the limit is 0 to x dx. Okay, and when I insert the x, I get x to the 5th over 3 plus x to the 5th over 5. And let me continue there, equals to k times, if I combine like terms, I get integral from 0 to 1, 8 over 15 x to the 5th dx, which is equals to k times 8 over 15 times 1 over 6 x to the 6th from 0 to 1, right? And then the integral here, as you expect, that will be 1, so we just multiply this. I can cross cancel this. This is 4, this is 3, so I get 4k over 45. That's the inertia with respect to x-axis. Okay, this is summer 2009 math 263 test 3 number 6.